All right, guys. So this is Algebra 2. This is Unit 1, Lesson 2. It's on relations and functions. And what you're going to see is a lot of the words that we use, the vocabulary that's used today, it is going to be very reflective of things that we've already gone over, like discrete, discontinuous, those words, continuous, relation from Algebra 1, domain and range, which we already covered this week. So the first part, a discrete or a discontinuous graph. When we say these two words, discontinuous object, we're referring to an object that is not connected. There's no curve in it. There's no line connecting a point to another point. There's breaks, and the object is disconnected. Whereas, so for example, these are discrete points. If I have this is a discontinuous graph because of the break in between here, right? Now, continuous graphs, they can be curves, they can be lines, they can be parabolas, but continuous graphs continue. They're connected. That is the distinction between discontinuous and continuous. Now, just an overview of relations. Any set of pair of points or ordered pairs of coordinates form a relation. Any set of ordered pairs or coordinates form a relation. So the set of all x values, they always go from left to right. And if I'm going in the left direction, if I'm going this way, I'm going to negative infinity. If I'm going to the right, I'm typically going to positive infinity if it's continuous. Okay? Now, this is the domain. This is the domain. X values, right? Inputs. These are other words for this. Domain, x values, inputs. Okay? Now, for your range, on the other hand, a little bit different there. Okay? Now, the set of all y values go up in a positive direction, and they can also go down in a negative direction. Okay? This is the range, also called y values, also referred to as outputs. Okay? There are 4 ways to write relations. This is way number 1. You can write them as a set of ordered pairs. The way we can tell the difference, we can just label the ordered pairs. We have x, a y, x, and a y, x, and a y, and x, and a y, x, and a y. It's very easy to distinguish the domain. So we're going to first write the domain. We're going to write these ordered pairs as a table of values. So just looking at your x values only, we have -3, -2, 1, 3, and -3. Looking at your y values, I have 1, 0, 2, -4, and 5. Now, what happens when I'm asked to graph these ordered pairs? Well, first, we want to make sure we can graph them. So I like to put directions when I'm graphing each point. And I'll show you what I mean. So for -3, 1, I'm going to go left 3, up 1, make my point. So left 3, up 1. Here's my first point. Then I go left 2, and I don't go up. Second point. Then I go right 1 up 2, right 1 up 2. Then I go right 3 down 4, right 3 down 4. Make my points. And for the last one, left 3 up 5. So left 3 up 5. And there's the graph of these points. There's the graph of these points. Now when you're mapping, you don't have to write repeating values. Okay? That just means they map in 2 directions. So your x's and then your y's. So -3, -2, 1, 3, and we don't have to put that last -3. I'll show you why. And then on the other side for my y values, I have 1, 0, 2, -4, and 5. Well, -3 maps to 1, and it also maps to 5. 2, -2 maps to 0, 1 maps to +2, and 3 maps to -4. Now we're going to write the domain and the range of each set. Okay? So my domain is, go to curly bracket, x bar, -3, -2, 1, 3, and -3. Close the bracket. My range, y bar, 1, 0, 2, -4, and 5. Okay? So we're going to flip the page. Keep going. Now, the next set, we have 3 ordered pairs. I'm going to go ahead and label them like we did before. XY, XY, XY. And we're going to put these ordered pairs in a table of values. I have -2 paired with 4, 0 paired with 0, and 3 paired with 3. Now, for my graph, I go left 2, up 4, left 2, up 4. I go 0, 0, so right at the origin, and then right 3, up 3. And I'm done. Now, if I'm going to map this, I can write all my x values. I'm going to label -2, 0, 3 maps to 4, 0 maps to 0, and 3 maps to 3. Easy peasy. Now, what about your domain here? Your domain is x bar, -2, 0, 3. My range, y bar, 4, 0, and 3. Close bracket. And that's pretty much all you need to know for a relation at this point in Algebra 2, because we're going to cover those things going forward. Now, your function is a relation. It is a relation. But the difference is every x value matches to exactly, you could put only, but exactly 1 y value. Let's reverse that. Every y value matches to exactly 1 x value. So while y values can repeat, x values cannot. So if I want to determine if a relation is a function, basically, when you have ordered pairs, if the x value repeats, you can make the conclusion this set of ordered pairs is not a function. Not a function. When you have a graph, use the vertical line test. And if a vertical line intersects the graph at more than 1 point, it is not a function. So we're going to work on this as we move forward in algebra. Okay? Let's scroll on down. So we're going to determine whether the following are functions. So first, for number 1 and 2, you can just label. Label all your x values. Look at them. Do you have any repeating x's? I have 5, 3, 2, and 0. No. So this is a function. There's no repeating x values. Okay. What about number 2? X, 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 x. Not a function. Why? Because ones repeat. What about number 3? 5, 3, 2, 8, 9. This is a function. There is no repeating x values. And number 4, I have -2. I have -1. I have 1 and 3. No repeating x values. All these points, there's only 1 point at each x value there. Okay? Now we're going to do a little bit more. We're going to identify the domain, the range, and whether a relation is a function. So the domain is, I'm not going to use x bar here, or it'd be hard to do. 5, 3, 2, 8, -9. My range, 1, 2, -3, 14, and 3. Function, yes, there's no repeating x values. Look at the next one. I have -2, -1, 1, and 3. So -2, -1, 1, and 3. This is a function. Yes, it is. Now for the range, I have 2, 1, -1, and -2. So 2, 1, -1, and -2. On the last one, I have xy, xy, xy. So domain of 5, 3, 7, and 0. So yes, this is a function. There's no repeating x values. My range, 4, -2, 1, and 3. Okay? Now moving on to how do I find the range and domain of continuous objects? So for this part, we are going to use interval notation. We are going to use interval notation. Okay? So when you have continuous graphs for set notation, your domain and range will be using inequality symbols. We did some of this last class. Less than or equal to, greater than or equal to. Okay? For domain, you're always scanning from left to right. Remember, left is in the direction of -infinity. Right is in the direction of positive infinity along the x-axis. For range, we're scanning from the bottom to the top, from -infinity to positive infinity along the y-axis. Now, first of all, if we're scanning from left to right, we're going to start at 0. Here's the next value. Here's the next value. And it's going more and more left, so it's going to negative infinity this direction. And then here's an x value on this graph. Here's another x value. Here's another, and it's getting more and more positive, because this is 1, this is 2, this is 3. It's going towards positive infinity. So my domain is negative infinity going to positive infinity. And we use parentheses around infinities. Now, your range, well, if I look, it starts down here somewhere. It looks like 2.1, negative 2.1. And then it gets more and more positive. It goes up to infinity. Your range, negative 2.1 to infinity. And is this a function? Yes, there's no repeating x values. Look at number 2. This is going to the left. This is going to the right. From negative infinity to positive infinity. Now, the range starts at -5, rides up to infinity. Yes, this is a function. What about number 3? Well, the domain absolutely cuts off right here. This is 1, 2, 3, -3, and it goes all the way. There's arrows, keeps going left, so it's going all the way to infinity. The range, on the other hand, is negative infinity to positive infinity. And no, this is not a function. Here's some repeating x values. These are repeating x values. There's two different points, two distinct points at an x value. Going to the bottom part, my domain, this is a straight line. Remember, for straight lines, it's always all real numbers, or negative infinity to positive infinity. The range, negative infinity to positive infinity. And if it's not vertical, it's always a function. The next one, domain starts at -4, extends to forever. The range starts at 1, and then it goes up forever. And yes, it's a function. Last one, domain goes from -2 to infinity. The range comes from negative infinity and goes all the way up to 5. And it is a function. Okay? So that's like review of the last unit. Very repetitive. And I did that purposefully. We're almost done, guys. The last parts I want to cover is function notation. And all function notation is just a lengthy way. Actually, it's not lengthy. It's actually shorthand. Function notation. It's just the way a function is written. It's meant to be precise in nature, and it's giving information about a function without a rather lengthy written explanation. And the most popular function notation is f of x, which is read f of x. So if I was looking at f of x equals 3x plus 5, it literally means, if you had to write this out, f of x equals x plus 5. It literally means that. If I had to write y equals 3x plus 5, not as bad. Means y equals 3x plus 5. These are the same. Now, what about the next one? This is an area problem. You'll see this soon enough. This means A of S equals S, we're going to write it out, squared. All right? So if you had to write that down, it would be rather lengthy, and it would be a lot more words, and you would not be able to focus on the main components of what we want you to remember. Now, what we're going to do is we're going to use function notation to find the range of the function f of x equals x squared plus 3 x minus 8, given these x values. This is an x of 1, x of 2, x of 3, and x of 4. I numbered them so I can be cautious and careful here. So for x of 1, f of x of 1, I'm going to plug in the number -2. So that's going to give me -2 squared plus 3 times -2 minus 8. This equals 4 minus 6 minus 8, which equals -10. There's my first one. Now for the second x value, or x of 2, I'm going to have f of 0, which equals 0 squared, plus 3 times 0 minus 8, equals 0 plus 0 minus 8, or -8. For f of x of 3, I have f of 3. This equals 3 squared plus 3 times 3 minus 8, equals 9 plus 9 minus 8, or 10. And for f of 6, f of x of 4, that's when x equals 6. I get 6 squared plus 3 times 6 minus 8 equals 36, plus 18 minus 8 equals 46. Easy peasy. Now, for the next one, we're finding the domain of h of x, the x values, when h of x equals 2x minus 9, given a range of -7, 5, and 11. So we're plugging things in. This is y1, this is y2, this is y3. All right? So basically, we have y equals, I'm replacing h of x with y, 2x minus 9. So y equals 2x minus 9. y1 for y2 equals 2x minus 9. And y3 equals 2x minus 9. So plugging these numbers in, I get -7 equals 2x minus 9. Add 9 on both sides. And doing the math, I get x equals 1. For the next one, you're going to add 9. You're going to replace y2 with 5. So 5 equals 2x minus 9. Add 9 on both sides. You end up with x equals 7. And the last one, the answer is going to be x equals 9. So rather simple, just involves substituting and some algebra. Replay the video if you're stuck or if you're confused. The last part of this function notation is function notation with graphs. So for f of 2 equals where x equals 2 is where x equals 2. But for f of x equals 2, y equals 2. Remember, f of x equals y. Remember that the x value is always inside of the function. It's always inside. It's located inside. Right there for f of x equals 2, there's no x inside. But here, there's an x value inside. It's inside of the f, and the f of x implies a y value. You're given a y value. if you're given x, substitute it in and find the y value. Okay, if you're given f of x, this is a y value. This sounds like a riddle, almost, the way I worded it, but read it carefully. One of my math professors actually told me that. It's like the best thing you could do is read carefully. Read very particular, like very especially and carefully. Last part, use it and find the x value. So if I wanted to find f of 2, I'm looking at where x equals 2. I go to 2, and I go down, and this y value is 1, 2, 3, 4, negative 5. For f of x equals negative 3, x equals 3, go over, n equals 0. Now here, y equals 5, and y equals negative 3. Is this a function? Yes. So when y equals 5, I'm going to go up. 1, 2, 3, 4, 5. Here we go, 5. Go over to my graph, and this x value is 1, 2, 3, 4, 5, 6. This is 6. X is 6 there. Last one, y equals negative 3. Down here, that means x is 0. And that's all the notes for lesson 2 for relations and function notation.